Remember this, Dave? Mythbusters firing a soccer ball out the back of a cannon. The truck's doing 60. They fire the cannonball 60 the other way. What happens, Dave? Let's take a look real quick. Do you know, Dave? Yeah, there you go, Dave. Now, Dave, I want to ask you something. I want you to think really hard about this. If I put a cannon on the earth and fire it like that, in the opposite direction of the earth's spin, what's going to happen, Dave? Yeah, there's going to be a change in momentum, huh, Dave? It's going to be just like that cannonball or that soccer ball, huh, Dave? It's going to be exactly like it, isn't it, Dave? Because there's no difference in motion, right, Dave? That's what they mean by that the frames of reference don't change the laws of the motion, Dave. The laws of motion don't care that you like to think that you can just look over here and, oh, I'll look at this frame of reference, and that means nothing else is happening. I'll just isolate it like magic, Dave. You're not a magic man, Dave. The earth don't spin, Dave. Tired of your crap, Dave. You are one condescending dude for being so stupid, Dave. What's going to happen, Dave, when we do that same thing on the earth? Well, let's see. We're going to take a visit to one of your go-to excuses, Dave. You like to say that two people throwing a ball on a train prove that you can't tell that there's any motion. Well, check it out, Dave. I think you're wrong about that. In fact, I know you are. Dave, if there's motion and it's touching another motion, like they're on the train, like we're on the earth, what happens, Dave? There's a big change. Do you see it, Dave? Do you see it? Look at the ball. Let's take a look at the path of all the balls and all the throws. Oh, look at that. On the top, Dave, you see that? That first throw, it goes 40 miles per hour, Dave, and the catcher only perceives it as 20 miles per hour, Dave, because he's moving too. But in reality, Dave, that ball's moving 40 miles per hour. And what about the next throw? Coming back against the motion of the train, Dave. You see that little dot? That's because that's what happened, Dave. That's the path of the ball, Dave. Looks to me like there's a big change in momentum, Dave. Does it look that way to you? I think it should. I think you should get it now, Dave. Looks the same, don't it, Dave? But oh, look what balls are moving. Oh, yeah, the target's moving on the bottom. You shot your ball like the Mythbusters, and it's got no momentum, just like it would have if you shot it on the earth, Dave. Now what's moving? Now what ball's moving after the impact? Oh, wow. The one you shot, Dave, the one you shot on the bottom cannon is moving after impact, Dave. You know why? Because it's the target that's moving towards the ball. Think about it, Dave. Is there any difference on the earth, Dave? Well, let's check it out and see. Let's just see. Let's see what happens, Dave. We're going to the magic sweet spot in the sky. The magic sweet spot. And guess what we're going to do, Dave? We're going to take turns.
See, Dave, what we'll do here is we'll take turns going through. Oh, look, I'm going to go again. We'll run all of our experiments.
And then we'll do it like this. Bring your cannon, Dave. We're going to have some fun.
Boom. We'll just shoot, and then boom, whatever we need to do. We'll do it that way. And then look, the cannon's just attached to the earth this time. We need a target still, but then we'll try it like that, and we'll just put it straight through, or we'll have your grandma kick it through. Boom. Always at the same speed, or any speed we want to test, really, Dave. That's what's really cool about the sweet spot.
The sweet spot. The sweet spot.
The coup de grace, Dave, is this.
The coup de grace.
And I don't even know what coup de grace means. I'll have to look it up. If it fits, I'll leave it. We're gonna rotate it through the sweet spot. So they'll all be the same. Everything will be the same, Dave. We'll get all the sizes right if we have to. See, Dave, look. Boom. And boom, Dave. Oh, boom, 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 boom. Do you get it, Dave? Do you get it, Dave?
Do you get it, Dave? Do you get it, Dave? We're going to go to the magic sweet spot. And we're going to run all of our tests in the same little sweet spot so that you can get your frames of reference figured out, Dave. Can you explain, Dave, why we got two different results? Your result is the one on the top. That's not what happens when the cannon's moving, Dave. Where's the difference? What happened, Dave? What's going on, Dave? Did you get lied to, Dave? Did you fall for a big, huge lie, Dave, and you just can't get over it? I think so. Can you resolve that, Dave? Can you fix this problem, Dave? Because it's going to require that you get your head screwed on straight. You've been lied to, bruh. So what's up, Dave? Why is it that we don't experience any of that stored energy that Tyson was talking about? What's up with that? Do we just ignore? You know why you ignore the rotation of the earth when your calculations, Dave? Because it don't move. That's why. That's why all your stuff comes out right, because it doesn't move. Man, Dave, I'll tell you what. You are a class act, I'll tell you that. Should they be the same, Dave? I've done them both correctly. Okay, you can see that there's no momentum on the ball. Should we reanimate it and show you what you do, Dave? You're not going to have westward momentum. Tell me how you get westward momentum, Dave. You should have never had it in your lifetime. You should have never had westward momentum in your lifetime. Now you're going to have to spend some time thinking about that, to process it, to make it fit right, because you've done it wrong for so long. You've done it wrong for so long. Anything moving west is still moving east. Can two eastward momentums a westward momentum make, Dave? No. Can two objects with eastward momentum cause a westward momentum?
According to the physics classroom, if an object is traveling eastward, then it has an eastward momentum. If the object is slowing down, its momentum is still eastward. Only its acceleration would be westward.
Truck's doing 60 east, pitcher's trying to throw 45 miles per hour west. What's going to happen, Dave? The ball's never going to go west, Dave. It's not. It's going to keep going east. Globies completely ignore the stored energy and the momentum we would have from rotating along with the Earth.